All right, so just in case, here's topographic maps. All right, again, if you're following along in your review book, it's pages 27 to 30. Okay, topographic maps is just a general term to take a flat map and be able to see things on it. Okay? In order to understand topographic maps, we actually have to, when we're looking at it, okay, you have to have some definition. You have to have some vocab. Okay? So the first thing you need to learn about is fields and field maps. What are they? Okay, and what is a field map? So let's start with a field. Okay, the field is the general location, okay, where you can measure a specific thing. Okay, so it's the area that contains measurable quantities. The area that contains measurable quantities. Okay, and a measurable quantity is pretty much anything, or it can be anything. Okay, it could be elevation. Put your iPads flat, please. It could be temperature. It could be pressure. It could be the concentration of food smell. Okay, it could be anything. It's just the area that has a quantity that is measurable. Okay, the value is the thing being measured. So that is the temperature. That is the pressure. That is the concentration. Okay, so you'll have the field, which is the area where you're measuring the quantity. Okay, the field value, which is the thing that's being measured. Okay, and then you have the magnitude, which is the actual value. Okay, so you have the field, which is the area where you can do the measuring. The field value, okay, which is the thing being measured in the field, and the magnitude is the actual value. Okay, so you have the area, the thing being measured, and the number. Okay, the next two definitions that I'm going to give you, all right, your physics teachers will be very happy if you remember them by the time you get to physics. So if you're planning on taking physics, dude, if I have to actually put your iPad down again, you're going to be in trouble. So stop taking pictures and start taking notes. Okay. So the next two, your physics teachers will be very happy. Okay, if you can remember the difference between a scalar and a vector. Okay. I'm always going to do that for you guys. I'm going to tell you what your next science teachers expect of you. I can tell you what your chem teachers expect of you because I taught chem for many years. And I have my degree in chemistry. And if you want to know anything about physics, if I don't know it, I can find it out. Okay? I just know what some things that they are expecting of you. First thing is to know the difference between scalar and vector. Scalar is just the magnitude. So it's just the number. Okay? So if you have a scalar field, It's the field, so the area, that is described in terms of magnitude. Yes. Sure. Scalar is basically just in terms of the number. That's what magnitude means, right? It's just a value, right? It's just a number. Versus vector has the number and the compass direction. So scalar is just the number, right? Vector is the number and the direction. So if you look at it, right, for those of you, and we're going to be going back to your weather app on your phones. If you have one, great. If you don't, you should definitely look up weather.com on your iPad and kind of favorite that as one of your tabs. Okay, because we're going to be going back and forth to this a lot, right? So if I said right now the wind is 7 miles per hour, that's going to give me the scalar, right? 7 miles per hour is just the magnitude, yes? But if I said it's 7 miles per hour in a northeasterly direction, that gives me the vector. So you see how it's the number and the direction, so therefore that's the vector, right? And all I'm doing, Anthony, can you see my phone? Okay. So if I give you the direction and the number, then that's the vector, right? If it's just the 7 miles per hour, then that's the scalar. Now, here's the thing, though. Pay very close attention. I'm still giving you units. I'm not saying 7. Are we talking about kilometers per hour? Are we talking about miles per hour? Are we talking about dollars? Okay. What are we talking about by saying the number 7? Right? I didn't give you anything. But if I say 7 miles per hour, that gives me the speed. That tells me how fast it's moving. The wind is moving at 7 miles per hour, and therefore that's the scalar. Versus the vector when I said in a northeasterly direction. All right, so scalar is just the number. Vector is the number and the direction. Got it? Good? Question?
So, like, when you said the field definition, you said, like, anything. So is that like living and not living?
What do you mean?
Like, you said a field is like anything within a region that can be measured.
Yeah, like you can measure the number of cows, right? Or you can measure the blades of grass, right? Bless you. Or you can measure the temperature values in different areas, right? You can measure the wind patterns in different areas. Like that all stuff is measurable. So it doesn't matter if it's living or non-living. Population density is another one that they use for these kinds of maps. Okay? The people that they're talking about are alive. Hopefully. All of them. Okay? Come on. Okay. So isolines are going to be like these lines in the background for those of you who can see them. Okay? What isolines in general are, the general term for, you guys ever played paint by numbers? Paint by numbers? Well, basically, like, you get a picture, and on the picture, like, all the 2s are supposed to be colored red, all the 3s are supposed to be colored purple. Okay, well, just think of the general idea. I'm not going to ask you to paint by numbers, but think of the general idea, right? Notice what I said. All of the 2s are supposed to be red. All of the 3s are supposed to be purple, right? What did I just do? I just grouped together the numbers by a specific color, right? Isolines are going to do the same thing, except we're going to play connect the dots, okay? Isolines connect the points of equal values, all right? I'll say it again. Isolines connect the points of equal values in fluid lines. They connect the points of equal values in fluid lines.
Yeah, last word.
In fluid lines. Okay. For fun, let me see what you see. Let's see if it's gonna work. Okay. All right. So here we have a bunch of different numbers. Want me to do me a favor? Hit the bottom left one for me, please. Thank you. Okay. These are just a lot of numbers. Most ISO maps or most topographic maps won't have this many, but I just want to do it so that you guys can see something. Watch how I do this. Right? I'm going to connect the dots of equal numbers. Right? All the 2's are going to go together. All the 3's are going to go together. At any point, did I create a very straight line? No. You have to be careful, okay? Because a lot of these things that you are going to do are going to be on your iPads. If you hold the line for too long, what happens? It becomes straight, right? So you want to make sure that you actually know what's going on here. Now, the reason why I did it this way with this little dip is I wanted to point out, okay? This gives me a lot of information, right? Just by looking at this, this gives me a lot of information. Right here, this gives me the contour interval, okay? And what a contour interval is basically telling me how much is each line worth, okay? So a contour interval tells me how much is each line worth. A lot of times, you're going to have to figure it out. It's pretty simple. Look at the lines and see what does it go by, right? In this case, we're going by 1. So that means the contour interval is going to be 1. Okay? The second thing that this tells me is you see these V's kind of that are created, right? You take your fingers and they make a V, right? Peace sign makes a V, right? Or as I like to call it, Pac-Man. Waka, 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 right? Just like Pac-Man, you make a V out of your hand. If Pac-Man is facing in this direction and going like this, which way is it going to go? To the right, right? Same thing happens with rivers and streams, okay? This here tells me that I have a river or a stream, okay? It's going to go in the direction where the mouth of Pac-Man will be. So you're going to say it goes outside of the V's. It goes in that direction, okay? Those are just some things that you are going to be responsible for knowing, okay? Where were we? Here we are. Okay, so let's talk about the different types of isolines. The types of isolines, guys, you're going to play word association. All right? The 3 main types that we are going to actually be using are going to be known as contour lines, isotherms, and isobars. And don't worry, I'm going to have you repeat that again. Okay? Contour lines is the first one. Okay? Contour lines, if you say the word contour lines, you're talking about elevations. Okay? We're going to focus on contour lines for the first part of this. It's isotherms and isobars later, but you do need to know the differences. Okay? You have contour lines, right? It has to do with elevation. Then we have isotherm, ISO, isobars are going to be about pressure. All right. And the reason for it is this. All right. A bar is a unit of pressure. Okay. A bar is a unit of pressure. No, I'm not just checking my phone to check my phone. If you guys all go onto your weather apps or weather.com, okay, and you scroll down to the bottom, right? What's up?
You said a bar is a unit of pressure?
So an isobar is going to be an isoline for pressure. ISO, B as in boy, A as in apple, R as in radish. Okay? So, right? If you were looking at this, right, everybody's looking at their weather apps, right? It gives you a whole bunch of information. It gives you the time of sunrise, the time of sunset. It gives you that it's 10% chance of rain. Oh, the humidity went down since last period. It's only 79%. Okay, gives us the wind direction. So far, there has been 0 inches of precipitation during this hour. You see where it says pressure, though? It says 30.13 inches of mercury, INHG. Okay, INHG stands for inches of mercury. That's what. There you go. Okay. Oh, you have it in. Wow, you have it in Pascal. Okay. I've never actually seen it that way. That's kind of cool. Okay. If you don't have it in inches of mercury, that's fine. Okay. You can change that, right, if you want to, but you don't have to. Okay. But that's also another inches of mercury is another value for pressure. The one that we're going to be dealing with mostly is going to be inches of mercury and millibars. Okay. Or lowercase m, lowercase b. Yeah, those inches of mercury. INHG. Okay, but I'm letting you guys know that now so that you can see it. I will tell you that standard or normal pressure is 29.92 inches of mercury for those of you who have that. Okay? Right now, we're above average, which is why some of you guys have a sinus headache right about now. Right? You feel some sort of pressure right here, some of you. But do yourself a favor, start looking at it. If you start getting a sinus pressure headache, you should look at the pressure, okay, and see, is it above average or below average? Right now it's above average, which means that it's going to rain, which means that once it starts raining, your headache will go away. Really funny story. My first year of teaching, I walk into this chem classroom, and I look at the kid in front of me, and he looks like he has had the worst night ever. He's half asleep, and I go, Steven, what's the matter? He's like, my head is pounding. I go, I got the worst headache too. I'm walking around like this. I'm like, guys, I promise you, it's just a headache. So I'm teaching, and I'm like this to the window. All of a sudden, I go, oh, it just started raining. And I turn around, the whole class goes in slow motion and looks at the windows, and on cue, it just starts pouring. And they're all looking at me like, are you a witch? Like, no, I'm not a witch. It's because the pressure changed because it started raining. And I asked Steven again. I go, Steven, how's your head? He goes, it's much better now. It's because of the pressure. The pressure will give you a headache or not give you a headache. And some people are more susceptible to it or not. Thought you guys might find that funny. Apparently you guys are really quiet today, but okay. So, all right, we have contour lines, isotherms, isobars. Okay. This map right here, and if you'd like to, you can. Don't get me in it, don't get anybody else in it. Okay? This map right here, on top, shows the actual landscape. On the bottom, it shows what the map would actually look like on paper. That doesn't give me a lot of information if you don't know what to do with it. Right? That just gives me a paper map, right? I don't know where the elevations are. I don't know where the steepest slopes are. I don't know where to figure out where to have camp, right? Where we're all going to go camping. Watch the difference. The difference between this map and the topographic map. Okay? The topographic map gives me a ton more information. This is the map that has the lines drawn in. Right? Which means we've already connected the dots. Okay? When you are looking at it, you can see that, you see how these lines are really super close together? Okay? Those lines that are super close together are going to tell me that the rate of change is going to be greater because over the distance, over a small distance, your contour value changed. Okay? And that means that's a really bad place to camp. Because that's one of those things where you just like walk off and fall down the side of the mountain. Okay? That means that there's what's known as a steeper gradient here. Okay? Gradient and rate of change. All right, remind me we're there. All right, have a good one, guys. I'll see you tomorrow. Or good luck tomorrow. I'll see you on Thursday.